All right, so let's deal with something like this, okay, where we have rational exponents, okay? Now, one of the things before I do this is realize that if I have a to the 1 over n power, right? So this is a rational power, it's a 1 over n. This is equivalent to an nth root. Okay, so that's one of the properties that between radicals and exponents. Okay, so we're going to use this in solving this. Okay, because we could split 2/3, right? We could split the exponent 2/3 as 2 times 1/3, and then use the power property for the power rule or power property or principle. For exponents. Okay, so let's do this. So let's rewrite this as 2. Now this is square, let's write it this way. Let's just do one more step. Okay, and I'm going to write this as x plus 1 squared, right? And taking the cube root, right? Well, actually, let me do one more step in there. So 2, let's do it this way. So we'll do x plus 1 squared, but then we'll put another power, because again, we're going to use the power of a power, right? So that would be 1/3. Because the power raised to a power, all we have to do is multiply these together to get back to here. So all I did was I split this up into power to a power. Okay? And then this, we just have to understand this is the same as a cube root. Okay? And again, we could exchange these. We could switch these around. It doesn't matter. Okay? So, let's do that. Let's switch these around and write this as 1/3 raised to the power of 8. You'll see why I did that. Okay? If I divide both sides by 2, okay, I get x plus 1 to the 1/3 power raised to the second power is equal to 4. So now what I can do is I can take the square root of both sides. Excuse me. So if I take the square root of both sides, I get x plus 1 to the 1/3 power is equal to plus or minus the square root of 4. Which is equal to plus or minus 2, right? So I'm just going to write this equal to plus or minus 2. Okay? Now, this here, again, is the same as a cube root. So I can write this as the cube root of that, right? X plus 1. Now, to get rid of the cube root, I'm going to raise the power of both sides to be 3. Okay? And so that will give me x plus 1 is equal to what? Either 2 to the 3rd, yeah, or x plus 1 is equal to negative 2 to the 3rd. So that means, let me do it up here. So that means x plus 1 is equal to 8, or x plus 1 is equal to negative 8. And that means x is equal to 7, or x is equal to negative 9. Okay. Now, before we test these, also notice back here, if I left this as an exponent, okay, of 1/3. Notice that if I raise the power of both sides like I already did to 3, the power rule, so power raised to a power, we multiply these. Well, if we multiply 1/3 times 3, we get 1, which is exactly the same thing that we ended up down here. Okay? So you can work with the exponents as well. Instead of changing it to a radical and then dealing with radicals, which you can, no big deal. You could also use the properties of exponents and just use solve it using the exponents too. But again, just a difference. I know the textbook uses the radicals. Since we're talking about radical equations, it makes sense to put things in radicals. Okay, so now 7. Again, we want to go back and test these points, right? We want to make sure that when we plug in these values, we get a true statement. So if we use 7 plus 1 is 8, right? 8 squared is 64, and, or no, actually let's do it easier this way. So if we get 8, the cube root of 8 is 2, and then 2 squared is 4, and then 4 times 2 is 8, which gives us 8. All right, good. So let's do negative 9. Negative 9 plus 1 is negative 8. The cube root of negative 8 is negative 2. Negative 2 squared is 4. 4 times 2 is 8. All right, so they both work out. Okay, so again, our solution set would be 7 comma negative 9. All right, have a great day.